Let's go on through the Test 5 tutorial. Be sure to work it as a homework assignment. It covers sections 4.1 through 4.4, which include the exponential and logarithmic functions. Question number 1 is simply a calculator question. You'll see off to the side where you would type in the base, then with whatever exponent key your brand of calculator has, then you would type in the 3.7 equals. That would give me the correct answer of C. Be careful when choosing the answers because B and C are very close. Question 2 is another calculator question using Euler's number. Remember, Euler's number is the letter E on the calculator. You would simply find the Euler's number key and enter the exponent 3.9. which in my example, the correct answer would be B. Now in question 3, you would have to first complete the graphing table of coordinates. You'll see off to the side where I have entered the base 2 and the exponent numbers that were given for x. When I enter those into my calculator or just work those by hand, you will see the corresponding solutions of 1/4, 1/2, 1, 2, and then 4, respectively. Now, examining these coordinates as ordered pair points, you will notice that they correspond only correctly to graph A. Now, in number 4, we're going to use the compound interest formula. The rate is always the percentage. The time is always the years. The principal will always be the original amount of money. Now the letter N in both places of the formula represents how many times a year is the money compounded. Here we see semi-annually, which means 2. I would enter those values into my calculator as given. Notice that I put a parenthesis around that 2 times 9. That just helps your calculator know that both 2 and 9 were in the exponent of the formula. When you work this out and round it off to the nearest cent, the answer is A. Here is another compound interest formula problem. This time the principal is 400 and our compounded rate is 12%. Remember to move the decimal point 2 places to the left to get 0.12. Then it's compounded quarterly. Well, that means 4 times a year, and the years would be 2. When you enter these values, the correct answer is C. For question 6, we have a compound interest, but this is called continuous compound interest. It uses Euler's number, E. You would first type in the principal, which is the original investment of $7,000. Then, of course, Euler's number is programmed into your calculator as the E key. Your percentage rate should be written as 0.09, and this is 3 years. So I would enter the values as shown, and the correct answer is C. In this question, you simply have to rewrite the log problem as a corresponding exponent problem. So the base is the 6, the exponent is the log answer of 4, and we would put that equal to 1,296. In question 8, you also have to rewrite a given statement, which this time it's stated as a base 5 with exponent -2 equaling the fraction 1/25. To write that as a log, you would write it as log of base 5, then put the 1/25 equals -2. Remember, a log is always equal to the exponent. Now in this question, you could tackle it a couple of different ways because the log key on your calculator does calculate a base 10 log. However, if you recall the inverse properties that we talked about, a base of 10 would cancel that whole number 10, leaving just 1. The answer is A, 1. Question 10 is similar to question 9. I could rewrite the square root of 12 as 12 with an exponent 1/2. Then I could use the inverse property and cancel log base 12 of 12, which leaves just 1/2, or the answer C. Likewise, you could enter this problem into your calculator. Question 11 could be rewritten. Instead of the fraction 1/10, I could rewrite that as 10 exponent -1. And then log base 10 of 10 cancels and leaves -1. The answer is B. Or you could enter it into your calculator. For number 12, I would definitely like to use the inverse property. So the base of 6 will cancel with the log base of 6 because they are inverses, leaving only the 19. Answer D. Number 12 could also use the inverse property because the log base 8 of the value 8 cancels, leaving just 18, or the answer B. Now number 14 could be rewritten. The fraction 1/10,000 is precisely 10 raised to the exponent -4. Again, if we use the inverse property, the log base 10 with a regular base 10 will cancel, leaving -4. Answer B. On question 15, you could again use the inverse property. It's a very good property to know. The reason it works is because the log has no base written behind the log. That means it's assumed to be a base 10 or common log. That means the two 10s would cancel, leaving 7, which is answer C. In number 16, we again see where there should have been an understood base of E, Euler's number, behind the abbreviation Ln, which stands for natural log. Both of these E's would then cancel, leaving the understood exponent of 1, which is answer D. In this question, we're asked to use the properties of logs. If you recall, 100,000 times x can be written as a sum or an addition problem. Then using my calculator or just your knowledge of logs, you can simplify log of 100,000 to be 5. The answer is 5 plus log x. Again, with the properties of logs, you may remember that a fraction can be rewritten as a subtraction problem. So I would rewrite the problem as base 2 log of 8 minus a base 2 log of y. Now that log base 2 of 8 will simplify to 3. So the answer is 3 minus log base 2 of y. Now in number 19, I would use the properties of logs, but I would first rewrite that radical sign. I would write that as the exponent 1/15. Then if you recall the power property for logarithms, the exponent property, you can bring down that 1/15 exponent in front of the natural log x. Number 20 is quite involved, but we can separate this logarithm. First, notice it's x times y squared. So I can put addition there. I would have log base b of x plus log base b of y squared. Then the bottom of the fraction should be subtracted. That's the quotient rule. So I will subtract log base b of z to the 4th. Now using the power exponent property of logs, any exponent inside of the log can be moved in front, which is what we've done when we get now log base b of x plus 2 log base b of y minus 4 log base b of z. Now question 21 is even a bit more involved because of the radical symbols. Each of the radical symbols, remember, can be written as an exponent. So the seventh root of m is really m with an exponent 1 over 7. The fourth root of n is really n with an exponent 1 over 4. And we separate the m, n, and k similar to the previous problems. Since the m and n were multiplied, we replaced that with a sum, addition. Then the k squared was in the denominator, so we subtract that. Moving each exponent in front of the log, we get the correct answer, A. Now for number 22, we see a log that is expanded. We wish to condense or put it back together. Since it's an addition between two logs with the same base, we can multiply their content, t and s. And when I multiply t times s, I would get the correct answer, C. Here is another log that is expanded, but we want to put it all back together in a condensed form. I notice there's subtraction, so that came from a fraction, and I also noticed there was a 1/3 and an 8 as coefficients. Those coefficients, or numbers in front of the natural log, would really be exponents. My final answer is B, natural log of x to the 8 over cube root y. In this question, we are asked to solve for x. There are several different ways to do this, and one of the easiest that I found was to match the bases. Look off to the right corner and you'll see the number 216. What I did is I divided 216 by the 6, that is the base given on the left of the original problem. If I continually divide by 6, I quickly realize that 216 is actually 6 with an exponent 3. When I look at the problem that way, then I know from my solving in section 4.4 that I can cancel those 6 bases and just leave 3x minus 24 equals 3. That's a simple equation at this stage, so I would add 24 to both sides, divide by 3, and the solution is 9. Here is another equation that's exponential that we could solve by matching the bases. It's a little trickier this time because 25 is 5 squared and 625 is 5 to the 4th. So I cancel the 5's and I bring down and distribute to get 2x plus 18 and 4x minus 4. When I solve for x, I quickly find the solution is 11. Here in number 26, we have to give two answers. The first answer is what they're going to call the exact answer. So I will need to rewrite the exponent problem as a log. So it's a base 5 log of 47. Now if you recall the base change formula, we could have written that as log 47 divided by log 5. Instead of log, the abbreviation ln for natural log could also be used. In either case, that would be your first answer, and the second answer would be the answer you get from the calculator, and that's approximately 2.39 if you round off 2 places. In question 27, I find the easiest way to solve this is to rewrite the log in exponent form. Notice the base is 2, that's the number directly behind log. The exponent would be the 4, and that's equal to x plus 4. When I simplify 2 to the 4th, I get 16, and then I solve for x. So the answer is 12. Here in the last equation, it's a bit long. I notice I have the addition of 2 logs, so that means a product. So I put x plus 7 times x plus 4. Next, I will rewrite the problem in exponent form. So the base is 4, the exponent is the 1, and that is equal to x plus 7 times x plus 4. To solve for x, I need to get rid of the parentheses. So I used the FOIL method, and I ended up with x squared plus 11x plus 28 on the right, as you see. Now, if I were to subtract the 4 on both sides to make this equation equal to 0, you get x squared plus 11x plus 24. Now, if I think about factor method from the beginning of our class, I could factor this trinomial as x plus 3 and x plus 8. So it looks like, technically, I have two answers, negative 3 and negative 8. However, negative 8 will not work in this problem. If you substitute the negative 8 back into the original equation, it makes it undefined because we never take the log of a negative number. However, the negative 3 would be overpowered. For instance, negative 3 plus 7 in the first parenthesis is positive 4. Negative 3 plus 4 in the second parenthesis is positive 1. Just by the fact that those are positives means that that negative 3 would be workable. So negative 3 is the only answer. Well, good luck on test 5 with all of these exponential and logarithms.